Welcome back, everybody, to the final session of keynotes before lunch. We'll first have a talk by Andy Feng, a distinguished architect on the platforms team at Yahoo. And he'll be talking about some of the use of Spark inside of Yahoo.
Good morning. So I think as many of you know, Yahoo has been a big player on the Hadoop land, right? So we developed the Hadoop for the search advertisement in the early days. We made it available as the open source in the Apache. Recently, we decided to expand our Hadoop stack to include Spark. I guess in this talk, I will try to answer two questions. So first question is why Yahoo care about the Spark at all? Then the second question is how Spark and Hadoop going to join together at Yahoo. So I will try to give those the technical, set level of the overview first. Then at that point, I will ask my coworker Tom, who is a Spark committer, to come up to cover Spark on Yahoo. That is the key technology we believe that are going to bring Spark and Hadoop together. So let's start with the business things. So as many of you know, the Yahoo homepage has been a crown jewel, is an important asset of Yahoo. In the early days of Yahoo, our homepage was carefully crafted by our talented editorial team. In 2012, Yahoo decided to take a data-driven approach to apply our technology to select personalized content for the Today modules that is the center of our homepage. So what we are doing is look across all those user activities. We found the popular articles for our user segments. So as showing up here, there's based on the age, gender, users' interest, geolocation, those informations. And once we select those, like a few dozen of the top articles, we create a machine learning algorithm for those. And then when the user visit our site, we calculate the scores for each model, each item for given user. Then we select the top 5 also the item for a user and put that into the Today module. So to our joy, what does that give to us from business perspective is that we saw the Today module click-through rates increase 300%. So that's the first kind of the taste of the machine learning at Yahoo, right? So with that, in 2013, we decided to expand our personalization effort beyond the Today module. So in the early 2013, we relaunched our Yahoo homepage. As outlined here in these screenshots, now most of the modules in our Yahoo homepage is personalized. So one of them, for example, so the top one was the Today modules, and bottom is the huge screen, depending on how big your screen is. So many articles will be included in this streaming module. In it, every piece of that article is personalized. For this one here, the first article was selected simply to be based on my personal, political interests. The second one was based on some interest around the high tech. And then among them, we even put some ads based on my social interest kind of stuff in it. And beyond the web, we also relaunched our Yahoo mobile applications. I mean, in the small screen, it is even more critical to bring the relevant information to the user. So as you could saw the iPhone app screenshots over there, those articles over there is selected based on, again, based on my interest. So there are the articles about the high tech, cover the Microsoft things. And among them, kind of in the bottom, there's articles that cover some of the news, the development in China about a political figure. Then we are pushing the personalization beyond the homepage. So here is the example of Yahoo Finance, right? So you could see in both the web and the mobile side, so all the most components, content over there again is personalized. For the finance here, so many of those articles are still based on the set of the stock symbols, why the individual user is following. So those are a few use cases of our personalization, right? Then there are several other use cases I could enumerate here, but let me just put one here. That's the search. So, for the web search, in the early days, we simply just put all, do the search of all the web pages over there. Then here, what we are doing now is that we are including, in addition to the web page, we are including some vertical content we found in our pocket. So in the Yahoo, we have lots of, in here, you see that the vertical content about the video, they have the image sense here, right? So the thing for this particular web search here, you see we inserted the first slot with the video content. In the fifth slot, we inserted the image content. Then you could imagine how we're doing those, right? So it's not for each individual users, each different query, you will see different places, so the vertical content got inserted. So what is behind it, again, is a machine learning algorithm in it. For the user and items, we are calculating the scores, and then we apply our business rules to decide at which particular slots we should insert all those content. So across all those use cases, what we needed is to apply the data science at a larger scale. So here's kind of my conceptual views of the world. So at Yahoo, we analyze a huge amount of the data about the user, about the items, and about their interactions. Then we apply machine learning to come up with the various models. And then we use those machine learning models against the live data, continuously update our knowledge about our users and about our item. So as a result, we will be able to produce our new homepage or improved Yahoo search. So what's behind the door here is one important figure in the stack. That is at Yahoo, we have a group of we call it the data scientists. The primary job of our data scientists is to develop the machine, in some way, is the machine learning algorithm they need to develop. So as a team working on the Yahoo platform, one of our job is to produce a platform that enable our data scientists to do their job efficiently. So with that, I would like to cover a few challenges has faced, by our data scientists. So first one I will call the science challenge. So let's take a look at our homepage again. More specifically, let's look at this streaming module, right? So if you think about today's module, as I mentioned earlier on, before, at a given point, we have a few dozen of the popular articles. And for each of those, we create a module, a machine learning model in it. For this stream module, on the other hand, the content over there, we are selected from the millions of potential entries. So as a result, we really could, we could not afford to create a model, for all those 1 million those entries. Instead, what we needed is to be able to come up with single models to cover all those items. So that's one. And the second, as is showing, if you look at the details, you could see why a particular piece of the content is recommended to me. Then what's behind here is for each item, we are looking into various features. And more specifically in Yahoo, we look all those, we are looking into the thousands of those features. Some of the, logically, each of the Wikipedia entity for us is a potential features. Right? So what we needed here is all those millions of items and the thousands of the features. We need to have one single model in it. Then the second is that on top of those the complexities, there is the object functions we try to optimize for. So in a typical machine learning algorithm, likely, in many of the e-commerce site or, a movie recommendations, those things, what's important over there is come based on the relevance. Try to find something that's relevant to users' interest. For Yahoo portal, on the other hand, relevance is just one of those things we need to worry about. For example, in addition to that, we need to worry about the freshness of the content and the popularity of the content, because those are play a big role from the user point of view. And on top of that, we also need to think about diversities, because you do not want to just bring all those the same similar kind of things on the page. You wanted to have the variety of the articles for user to look into it. So under such context, many of our Yahoo data scientists, they are exploring machine learning algorithms. For example, for our streaming model, stream module here, some of our data scientists was looking into the content-based recommendation, algorithm, such as the logistic regressions. Because that would enable us to do is whenever some new article showed up, we just based on users' previous interest, we found them. On the other hand, some other data scientists are looking into the collaborative filterings in here as well, because that will enable us to do is bring the new type of the articles to the user, because based on some user who visit the other users, what kind of articles they are seeing, we will bring those articles to you. And some other data scientists even tried to look into the hybrid of those various combinations. So from the platform point of view, we really need a platform enable our data scientists to explore all those different types of the machine learning algorithms. So that's challenge number one. Then the challenge number two, I will call it the speed or latencies. So part of the nature of our news articles, so many of the things Yahoo serve is very time sensitive. So here is an example of some of the information I'm sharing here about our today module over 2 days. Each curve here is an item in the today module. So if you see some of the line over there very short, right? So they are the article showing up in our today module. Some of them are only showing up there like 2 hours or even less. And even during the period the article is available on the today module, the click-through rates could change very dramatically over the time. And then if you, in addition to those, if we're thinking about the breaking news, all those things, right? So it's clearly how fast you could come up with the data model is very critical. So at Yahoo, we are aimed to build the machine learning models at least every hour. So that's on challenge number 2. So here's another challenge. What I will call the scale, because it kind of truly is. And then at Yahoo, we have 150 petabytes of data available for data scientists to look into it. All those data currently is available on the Hadoop stack inside of our HDFS. So from our data scientist point of view, all those data are really important for them to do their job. So what is important here is we need to find ways to enable our data scientists access those data efficiently. For example, we could not afford to copy, moving the data from one cluster to another, because that's just going to take too long. Then on the top of that, and we have 35,000 machines available on our Hadoop stack for our data scientists. That's why many of our data scientists have really love Hadoop, because this kind of those are the tools that enable them to do their job. So with those 3 challenges in mind, what we decided to do is to expand our big data platform to include Spark in the mix. What we are saying here is Hadoop going to continue to be the core of our big data platform. And Spark will be additional solutions there with a focus on iterative processing. And both the Hadoop job and the Spark job going to be executed in the single cluster. And they will be allocated resource by our preferred resource manager, Yang. And both the Hadoop job and the Spark job will have access to the same set of data resources. By doing so, we tried to address all those 3 challenges I mentioned earlier on. From the science exploration point of view, we believe the abstraction provided the Spark, ML architecture will enable our data scientists to do their job more efficiently. And with the in-memory processing capabilities provided by the Spark, and we are aiming to dramatically reduce the model building time. And with the Yang to bring all the data sets and the server for our data scientists, we hope most of the scaling issue will be addressed. So with that, we have a few early pilot projects based on this new expanded big data platform. So let me just share 2 of them with you. The first one is for our e-commerce. So at Yahoo Japan, we happen to have an e-commerce website. Currently, is the #1 in that region. So just like many of the other e-commerce sites, when a user is visiting a site, looking into a particular shopping item, we wanted to enumerate several other things for the user to look. So this is the use case of the collaborative filtering. So one of our data scientists decided to try out this Spark. Here is how much code he wrote, 30 lines of the code. And then using this 10 machines, he was able to rebuild his model in 14 minutes. And compared with his previous job on the MapReduce platform, about 2 hours, that's a good improvement. So that's kind of the interesting story for our pilot project. So here's another one. right? So as I mentioned earlier on, we have streaming modules in our home page. Among them, in addition to the content, we have some ads in it. For that ad, until we have, in the production, what we have now is a VW-based logistical regression algorithm. And as for the people who know VW, it is a very powerful logistic regression library one could use. But on the other hand, it has some of the limitations. For example, it's a little bit harder to extend it and have some scalability kind of things one may need to worry about. So instead of trying to fix the VW, one of our data scientists decided to write algorithm, a simple logistic regression algorithm in Spark. Again, very simple algorithm, 120 line code. And then he launched this thing on the Hadoop cluster. And for 100 million samples and 13,000 features, he was able to build his model in 30 minutes. Quite good. And to me, I think most exciting is when he finished his first version of the algorithm, he sent out us an email, basically say, I launched my, Spark algorithm, models running on the Hadoop. So I think I would literally remember that because it was on about 2 hours earlier, we made this Spark on Yarn available for Yahoo. Because traditionally, many of our data scientists had this really hard time to, either to access the data or set up the things, sometimes even take weeks. Here we have a story that launch a new, one version, some application in 2 hours. So with that, with those kind of the success or the joy we have in our pilot project, we believe Spark going to play an important role at Yahoo, especially for our machine learning. Just to be clear, Hadoop continues to be the core of our big data platform. And for the success of the Spark, Yahoo has tried to make our portion of a contribution. So some of our developers have been quite active in the community. And with 4 of them are the committers in the Apache Spark project. We have been working on the Spark on Yarn, Shark, and several other areas. And among those technologies, I think, as you could imagine, Spark on Yarn is a key technology for us to bring Spark and Hadoop together. With that, I'd like to invite my coworker, Tom, onto this stage to give us an overview, quick overview of the Spark on Yarn. He is our new Spark committer.